So we use product rule when we have two or more functions that are in product. In other words, you are multiplying functions. Common knowledge would state, well, if I want to take the derivative of, say, function f and function g, you would apply limit laws and stuff. Limit law suggests, well, the limit, or if I want to find the limit, all I have to do is find the limit of f of x, find the limit of g of x, multiply them together, end of story, right? And I mentioned that most limit laws can be applied to derivatives, the key word being most, not all of them. So I can't do this. What it means is I can't simply find the derivative of the first function, derivative of the second function, and multiply them together to find the derivative of the products of two functions. That is incorrect. But there is a formula. If I define u to be f of x, v to be g of x, the derivative of u with respect to x is u prime. The derivative of v with respect to x is v prime, or f prime of x, or g prime of x. It's entirely up to you how you call it. But the rule is quite simple. I like to write it this way always. So you multiply u with v prime, v with u prime, and add them together. So the derivative of f of x multiplied by g of x simply means u times v. It's the same thing because u is f of x and v is g of x. So what is the formula? The formula is u v prime plus v u prime. Good. So that's the formula. Well, anyone can memorize the formula, but is that true? Why is it true? Gio asked me a long, long time ago. So this is why. So u is f of x and v is g of x. So in terms of u, I could write a change in u, delta u. I'm not going to use the letter d. I'm going to use delta because I haven't taken the limits yet. Last time, when I wrote last time or the time before, when I went with the notation of the derivative, I said from delta we go to d as we take the limit h approaches 0 in the difference quotient, or delta x becomes really, really small. So what would delta u be? Delta u is simply change in f. We all know what that is. X plus h, instead of h, I'm going to call it as delta x. correct? And in a similar manner, delta V would be G of x plus delta x minus G of x. Change in V is simply G of x plus delta x minus G of x. Now we want to find delta UV, right? So that would mean I want to find the net change of f of x plus delta x, g of x plus delta x, and then minus f of x, g of x. I could write this as change in u, which just change in if I treat u as is, all I'm doing is adding a little bit delta u, and v, I'm adding a little bit delta v, and subtracting uv. So I'm going to treat this entire thing as a function in and of itself. If I did that, I would get uv plus u delta v plus delta u times v minus uv. I will leave that part as is for the time being. What happens to uv? It'll get cancelled. Same logic, the numerator of the difference quotient, the original function will always get cancelled. In this case, that original function is f of x times g of x, u times v. And u times v will get cancelled. Now missing a term, which is delta u times delta v. I just foiled, so uv, u delta v, v delta u, delta v. The uv gets cancelled. So all I'm left with is u delta v plus v delta u plus delta u delta v. And that simply is delta uv. Do we agree? All I'm measuring is how u changed and v changed. So that would be u plus a tiny amount of change in u, v plus tiny amount of change in v, and I'm subtracting uv from it. Standard difference quotient approach. I still haven't found the derivative. Since u and v are functions of x, I have to divide by delta x, which is the change in x. On both sides, of course. So you will have delta uv divided by delta x equals u delta v over delta x plus v delta u over delta x. Here, it doesn't matter where you put the delta x. In the first two terms, I put it under the delta, but here really doesn't matter since both terms have delta. And that's what we will have. Do we agree?
Yeah, did you get the V delta view? The sign,
This one,
yeah,
u times v.
oh, it's just because you just
For
put it
you.
in the second one, so I just didn't know.
Yeah,
Okay.
for you. Good so far. So how do we go from delta to the letter D? What is the meaning behind it? What does delta represent?
Change.
What type of change?
It's change.
Huh?
The rate of change.
Rate of change, but there are two types.
Instantaneous.
Instantaneous, what is the other one? Average. Delta refers to average rate of change. How do we convert average rate of change to instantaneous rate of change? We have to do something. Take the limit of h approaches 0. Which delta here plays the role of h in this expression? What?
Delta x.
Delta x. So what I'm going to do so take limit delta x approaches to 0 on both sides, so that so the limit delta x approaches to 0 for the first term, limit x delta x approaches to 0 for the second term, and good. Again, relative to the rate of change in x. In the difference quotient, h approaches 0, here delta x approaches 0. So we can't simply get rid of that h from the difference quotient. It is always there. So this part needs to stay because when we apply delta x approaches 0, it will have an effect right there. Do you agree? It certainly will do that also, but in the sense of a derivative, if we want to find the derivative, in other words, I want to convert the delta to a d, the limit has to apply to the denominator. So I'm going to pull the u out, And that's what I would have. Here, same argument. That is the rate of change, the average rate of change. I need to get the instantaneous rate of change. So I've got to make h as small as possible. In this case, delta x has to approach 0. So this limit could only apply to that. So v multiplied by limit delta u over delta x. That leaves us with the very last step. Limit delta x approaches 0, delta u over delta x. We also have delta v over delta x if you rewrite. It's entirely up to you. But let's say I just want to find the change in u. Let's say I just want to move this over here, keep it as is. Still a derivative. I want to do delta x approaches 0. But in this case, this would become a rate of change. Agreed. Rate of change in b with respect to x. Rate of change in b with respect to x. Sure, I can apply the limit here, apply the limit there, but it's going to become 0 here. And the rate of change here will be a function of some sort. It's just v prime when you take the limit. It's not going to be 0, rather it will become v prime. So I am going to take the limit of delta u as delta x approaches 0. That is delta u. Yes. What would happen when delta x approaches 0? Just delta u. Let me repeat the question. What would delta u equal to if delta x approaches 0? It'll become 0 because that's going to become 0. F of x minus f of x is 0. So that term right there will become 0. Yes. Bye last term. From last time, if the difference quotient, in the difference quotient, if h approaches 0, the delta becomes 18, correct? That was our argument. That's what's happening here. Delta x is approaching 0. If you treat delta x as h, the denominator is getting smaller and smaller. So from an average rate of change, you're going to an instantaneous rate of change. So I can rewrite that as u times dv over dx, correct? Logic. Same v times delta x is approaching 0. In other words, you're changing the average rate of change, or the average rate of change becomes the instantaneous rate of change. I can change the letter delta like this. Good. But what is dv over dx? It is the first derivative of v with respect to x. I can use a different notation. What is another notation?
First, second.
What?
First and second.
First and second? Well, this is the first derivative of v with respect to x. I can write it in a different notation.
duv over dx.
That's what we're trying to find.
You talking about like what we did with like x and y when we had it squared? Is that what you're trying to do?
Can I erase this?
Yes.
Okay. So I took the limit delta x approaches 0 on both sides. On that side, after I applied the limit, average rate of change became instantaneous rate of change. So I wrote it as dv over dx. Well, v times du over dx. Agreed so far. Same argument here. If it is delta, which is the average rate of change, and if I make the denominator or change in x really, really, really small, that average rate of change would become instantaneous rate of change. We saw this last time. So delta uv over delta x would become d over dx of u times v. That's what we wanted to find at the very beginning. Well, I showed you a different notation, which is concise, so that we can represent a first derivative in a nice way. Prime, think of Amazon. So u times v prime. That's v times u prime. Isn't that the formula that I wrote at the very beginning? Does that make sense as to why that formula is true? Now, anyone can memorize that formula, but we need to know why the formula is true. This is why. That's a lot to explain why. Yes. Knowledge doesn't come easily.
We have a question. So what you're saying was that delta wasn't an instant rate of change, right? So you made it an instant rate of change.
So exactly. So what I had was an average rate of change. The moment I take this limit, I'm going from an average rate of change, making that x really, really small, and trying to make it an instantaneous rate of change.
That makes sense now why the equation is like that.
Right. So delta becomes d over dx represents instantaneous rate of change. Delta u over delta x is average rate of change. So how do we make an average rate of change instantaneous? By making the distance between 2 points on the x-axis really small. In other words, delta x must approach 0.
That's a long process for a little thing.
Yes, you asked for it.
I did.
If I asked you, well, how would you find the first derivative of this? What would your answer be? Based on what we learned in the previous section, how would you find the derivative of this?
Multiply the two together and then
Multiply the two together, and then what?
and then you find the derivative.
And then you find the derivative. So in other words, what Gio is trying to tell us is I distribute that e raised x, correct? So we will have 2x squared e raised x minus 3 e raised x. Good. That is easy, correct? Derivative of 3 e raised x is simply 3 e raised x. What about that part? You have x squared multiplied by e raised x. X squared is a function, e raised x is a function. So you're trying to find the derivative of the product of two functions. Do we agree? Okay, so if we want to find f prime of x, which is the derivative of that, The derivative of the first term is the difficult one, so I'll write that separately. The derivative of the second term, we all know if you have sums or differences, you can distribute the derivative directly in. So this d over dx can simply move right in. So the derivative of the first term minus the derivative of the second term. We know the derivative of the second term is minus 3 e raised x. Yes? All we need to find is the derivative of the first term. And we're going to do that here and plug it back in here. Would the derivative affect the constant that is multiplied? No, you can pull that out. But the derivative needs to be applied to x squared as well as e raised x. Well, we can call one as u and the other as v. Does it matter which one is u and which one is v?
No.
Jessica, right?
Me?
No. Starts with the J.
Starts with a G.
G. Okay. What is it?
GR.
G. A bit far from J. So why Gianna?
Because they're just being multiplied.
They're just multiplied, whether it's 2 times 3 or 3 times 2, same thing. I like to call the first term as u, the second as e raised x. V prime, u prime. For a minute, I lost my thought to one of my cats. Her name was Vuvu. So every time I do border pro, it reminds me of Vuvu. Get it, UV.
Oh.
Vuvu. Okay. May she rest in peace. Okay, so u equals x squared. V prime equals e raised x, and v is e raised x, u prime is 2x. And I just multiply them together and add. So the derivative of that would be x squared e raised x, 2x e raised x. What do we have in common? Just e raised x
X.
and x. So 2x e raised x multiplied by x plus 2. That is the derivative of the first term. Agreed? I can simplify this or write it in a very nice way because I have 2 factors in common between the first term and the second term. What are the 2 factors? Or what is the factor? E raised x. So if I pull that out, 2x times x plus 2 minus 3. Good. That's the derivative of that function, which is the product of 2 functions. Yes.
2 questions, okay, so you can't fit the let's say the 2x squared minus 3x, you can't put that in product rule from the beginning or no?
And that's a very good question. Do you follow this question?
Well, we shouldn't, but could you, just possibility.
So his question is, instead of distributing, could I have done it with product rule from the very first step? In other words, calling this as U and that as B. Would that be okay?
Maybe.
Yes, by all means, that's the most effective approach. So having
I knew
you
it.
here and doing that. The reason why I brought up distribution into the function is because of the next problem that I'm going to give you. Are we clear with this one?
But I have another question.
Yes, go ahead.
Let's say we had that same one, f of x, but then we have g of x, which would be like 2x cubed plus 5. Could I now, then we could put f of x, that whole thing, f of x as u, and then g of x would be like the b, something else, and would that work?
Like 2x cubed plus 5 for B.
Yeah, for g of x.
Okay, it will work. Yeah, so you read my thought process, Gio, that's exactly the next problem. Yeah, you will see when I do this. Are we clear with this problem? Okay. I use the distributive property here for a reason. I want you to find the derivative of this function without using the product. Okay, so my condition here was to solve this or find the derivative without using product. Yes? And what did we do in the previous problem? We distributed and then we started the problem. So that's the idea here. The idea is to distribute or FOIL, then break it down and use it, use the power rule to find the derivative. So if you rewrite x squared multiplied by x raised 4 is x raised 6. X squared times 1, x squared. Negative 3 times x raised 4, negative 3x raised 4. Negative 3 times 1, negative 3. What is the derivative of x raised 6?
6x raised 1.
Derivative of x squared. Derivative, well, 3 would remain as is. What is the derivative of x raised 4? And the derivative of a constant, 0. What do we have in common? 2x. 6x raised 5, if 2x comes out, I'll have 3x raised 4. 2x plus 1. 2x comes out of that, minus 6x squared. And we always like to write a polynomial in decreasing powers of x. So let me be OCD and write it this way. Good. Great. What if I wanted to do the exact same problem using product rule? Would I get a different answer? No, that's a lot. What is U prime?
4x 5 minus 12.
U prime.
Oh, my bad. I forgot.
Well, you might have called it different, it's entirely possible. Derivative of x squared is 2x. Derivative of x raised 4 is 4x raised 9. So the derivative of our function x squared minus 3 times 4x raised 5 plus 2x times x raised 4 plus 1. Good.
Oh, I think you're wrong with the b prime. Why did you raise the power for b prime? I thought it was supposed to go down.
Thank you. Because I've been looking at your answers. X raised 5. See, there is a 4x raised 5 that's got 4 parts. So 4 times x cubed multiplied by x squared is 4x raised 5. Minus 12x cubed plus 2x raised 5 plus 2x. I can combine 4x raised 5 and 2x raised 5, 6x raised 5 minus 12x cubed plus 2x. What do we have in common? 2x. If I pull that out, I would have 2x multiplied by 3x raised 4 minus 6x squared plus 1.
Will this always work well?
Yes.
Okay. Is that not where you weren't supposed to second multiply?
Come again?
I thought you weren't supposed to just like take the derivative of each and then multiply.
I didn't do that,
Okay.
right? If I took the derivative of each and I multiplied, this would be 2x. That would be 4x cubed. Multiply the two together, the answer would be 2x, 4x cubed, 8x raised 5. That's the wrong answer, right? What I'm doing is I'm splitting the two as u and v, and I'm using the product rule. See the difference? So I'll show you two approaches. One is this, other, that. Of the two, which one should you use?
Second one.
Well, that's what you did. Which one do we prefer? First or second? First. How many of you say first? Oh. How many of you like the second one? Okay. The second one is this. People who like the second one are genius. No. It is completely a matter of choice in this problem. The reason why I brought this up is you don't need product rule all the time. It depends on the problem. Here, I mean, I would always go for the product rule. That's just my practice. But if you like foiling and using the power rule, go for it. From your perspective as a person learning calculus, I think this is the approach that you would like. But eventually, when we get into trigonometric functions and stuff, you can't do that directly, so you will need this. So understand the product rule with simpler functions so that you can use them with complicated functions. So, a few things. First mistake, it is very easy for someone to make this mistake, taking the derivative of x, taking the derivative of e raised x, write it as e raised x. Life is not that easy. I keep reminding you that. I will explain the second mistake once I find the derivative. So u is x. And v is e raised x. U prime is 1, v prime, e raised x. What is the first derivative? U v prime plus v u prime. V is x, excuse me, u is x, v prime is e raised x. V is e raised x, u prime is 1. Good. Now, sure, I can find the derivative using this, but factoring is a great thing. So always, if you can factor stuff, factor it right away. So if we have e raised x in common, so e raised x, if you pull it out, you'd have x plus 1. Yes. So the second mistake, when you find the derivative, since we are asking for the second derivative, evaluate to that x is equal to 2. It is only natural to plug into and call it as 3e squared. Yes. But it is incorrect. Why?
Because you're not the second derivative.
If you took the second derivative of this, what would happen? What is 3e squared? We did this last time. Trick. It's a constant, it'll be 0. And you end up saying that the second derivative is 0. Could it be 0? Could be for some function, but not for this one. That's wrong. So the next step would be to find the second derivative, then plug in the value of x. So f prime is that term. Now I'm going to call that as u and that as u. Once you have good amount of practice, you will start differentiating and writing it right here in one line. But until that point, I recommend you doing this. U is e raised x, v is x plus 1. U prime, e raised x, v prime is 1. The second derivative will then be u v prime e raised x times 1 plus x plus 1 times e raised x. What do we have in common? E raised x. So 1 plus x plus 1. Good. So you will have e raised x times x plus 2. And now you can plug in the value 2. So at x is equal to 2, f double prime of x is simply e raised to the power of 2. 2 plus 2, 4, which is 4 e squared. Good. You can do it this way without factoring, that is okay, but factoring will make things simpler.